about carbon dating? I get asked this question all the time. Jonathan spent $70 to get this book, right? And the new one's out and it's $80 now? $80. $80, okay. Radioisotopes in the Age of the Earth, the RATE project, R-A-T-E. I am sure not the world's expert on carbon dating, but I think I can explain things. I'm a teacher. I can explain it as best I can. That's what a teacher's supposed to do. Take the complex and explain it where the average person can get it. And say, since I operate about 4th grade level, you know, I got to understand it myself first so I can explain it. Let me explain how carbon dating is supposed to work, and then tell you the serious problems with it. Carbon dating was not invented until 1949, in the last 60 years. So when they started telling the kids the Earth is billions of years old, back in 1830, they didn't tell them because of carbon dating. They'd never thought of carbon dating, never been heard of, okay? Why were they teaching the Earth is billions of years old 160 years ago? Well, because they needed billions of years to make their theory look good. That's why. I mean, if I told you a frog could turn into a prince if you kiss it, you'd all say, well, it's a fairy tale. But if I told you, hey kids, the frog can turn to the prince if you wait billions of years, maybe so. Now it becomes believable. No, it's still a fairy tale. It's a stupid idea. But the geologic column is where it all started. We covered that on video 4 and some more on video 6 about the geologic column. The Earth was divided up into layers: Cenozoic, Mesozoic, Paleozoic, Archeozoic. Each layer was assigned a name, an age, and an index fossil. We covered that on video 4. Then they said, now we have to prove these layers are old. So they picked the numbers out of the clear blue sky, and any dating technique that comes along, like carbon dating or any other, has to match the geologic column or it's rejected. Only because the geologic column's been taught for 180 years now. So surely it's true. No, just because it's been taught 180 years doesn't make it true. But that's the logic the scientists will have. Well, we know the geologic column is established, therefore any carbon dates we get should match that. If they don't, we'll throw them out, and we'll keep testing till we do. They might have to test a sample 5 or 6 times till they get the number they want. Well, how do you know any of them are right then? If you're getting a different number every time, how would you know any of them are right? Radiometric dating would not have been feasible if the geologic column had not been erected first. Ever since William Smith at the beginning of the 19th century, fossils have been and still are the best and most accurate method of dating and correlating the rocks in which they occur. Apart from very modern examples, which really are archaeology, I can think of no cases of radioactive decay used to date fossils. They don't date fossils by carbon dating, they date them by their geologic position. That's how it's done. But here's what happens. Earth's atmosphere is about 100 miles thick. Space shuttle, in order to get free from friction, has to get up about 100 miles to be able to outside the air. And, you know, straight up, 100 miles is not that far from here to halfway to Tallahassee, you know. But if you go up, look at the atmosphere, it has very distinct layers to it, which is kind of interesting. It has a heat sink where it gets very, very cold, up about 7 or 8 miles up, like 80 or 90 or 100 below zero. But the Earth's atmosphere contains mostly nitrogen, 78% nitrogen, 21% oxygen, a little bit of CO2 for plants to breathe. Well, these don't breathe it, they're fake, but plants breathe in carbon dioxide. And there's a very tiny little bit of radioactive carbon-14, 0.0000765%. This radioactive carbon-14 is different than regular carbon. It's produced by radiation striking the sun, striking the atmosphere. Sunlight strikes the atmosphere, slaps the nitrogen around, and turns it into carbon-14. So it all starts by the sunlight hitting the atmosphere. Just to give you the procedure here, about 21 pounds of carbon-14 is produced every year, and that is spread out all over the world. If I told you there's 21 pounds of gold, but it's spread out equally all over the world, forget it. I'm not even going to go look for it. Okay? You're not going to find it. Real tiny amounts. If you look at a periodic table, carbon and nitrogen are right next to each other. Nitrogen has an atomic weight of 14. Carbon has an atomic weight of 12. But if the sunlight slaps the nitrogen around, it'll knock a few things off of it and it becomes carbon-14. So it still weighs as much as the nitrogen, but now it's considered a carbon. It's called radioactive, which does not mean it listens to the radio. It's just, it's unstable and it's going to break apart. It's like 3 guys dating the same girl. That relationship's not going to last, okay, forever. Something will go wrong, right? Find the one you want, Jonathan, and just marry her and be happy the rest of your life, right? Carbon-14 is unstable. It does not like being carbon-14. It wants to get out of this situation, so it breaks down. about half of it will break down on a statistical average. About half of it is going to fall apart every 5,700 years. Now, it is doing this on a purely random procedure. I mean, you got a pile of molecules. You never know which one's going to fall apart. But statistics tell us about half of them will fall apart every 5,700 years, roughly. Now, while it is carbon-14, it's floating around in the atmosphere, like the rest of the carbon, and it latches onto oxygen, like carbon often does, and becomes carbon dioxide. And they hook up, and they're happily floating around the atmosphere. And the plants are breathing in CO2. Animals come along and eat the plants. So the only way carbon-14 gets into the living world is from the atmosphere. It's produced by the sun, striking the atmosphere. Plants breathe it in, animals eat the plants. Probably during your lifetime, you've either eaten plants or you've eaten animals that have eaten plants. How many have ever done that before? Like today for lunch, right? Okay. Everything we do is from one of those two sources. It's plants or it's animals that ate plants. Well, the plants are absorbing CO2. Some of it is radioactive. So if the atmosphere contains 0.0000765%, it is assumed that the plants also have 0.0000765%. Probably a reasonable assumption, and I don't argue with them. I just point out this is one of dozens of assumptions that can enter in to really mess up things like carbon dating. So probably you have 0.0000765% carbon in you, because you've been eating these plants or you've been eating the animals that have eaten the plants. So probably it's all balanced in nature. When the plant or animal dies, it stops eating, stops taking in more C14. It stops breathing. Okay? Now whatever it had is going to decay. It was decaying while it was alive, but now there's nothing to replace it. So what they do is they compare the amount of C14 in the fossil with the amount in the atmosphere and say, wow, this fossil's only got half as much. Therefore it's been dead for one half-life, 5,700 years. Because it continues to decay after it died, but now it can't be replaced. So while it was alive, it should have had about 0.0000765%. If it's only got 0.0003825%, it's been dead for one half-life, or two half-lives, or three half-lives, etc. In theory, it never goes to zero. But for practical purposes, you can't measure beyond a certain amount. You know, you're going to run out of stuff to measure. It goes from a half to a fourth to an eighth to a 16th to not enough to measure. Great article came out from Institute for Creation Research. They're the ones that did the RATE project, ICR.org. They said, with their short 5,700-year half-life, no carbon-14 atoms should exist in any carbon older than 250,000 years. It should all be gone. Yet it's proven impossible to find any natural source of carbon below the Ice Age that does not contain significant amounts of carbon-14. Even though such strata are supposed to be millions or billions of years old, conventional carbon-14 laboratories have been aware of this anomaly since early 80s and have striven to eliminate it and are unable to account for it. Lately, the world's best such laboratory, which has learned during 2 decades of low C14 measurements how not to contaminate specimens externally, under contract to creationists, they confirmed such observations for coal samples and even for a dozen diamonds. Now think what that means. The textbooks will tell you coal formed 250 million years ago in the Carboniferous era. And yet when they test coal, it still has carbon-14. How is that possible? If all the carbon-14 atoms would have disappeared in, say, 30, 40, 50,000 years, why would there still be carbon-14 atoms in coal? I got an idea. It's not 250,000 years old. Ooh, boy, they don't like that answer. They'll keep searching until they find another answer because they don't like that one for sure. And diamonds, which they say, formed millions and millions of years ago, they still have carbon-14 in them. And it's not possible to contaminate one of those things. I mean, it's the hardest substance we have. So how do you get carbon-14 in diamonds? And when did diamonds form? Well, I'm not sure when they formed. I know Superman makes them in a few minutes. Take a piece of coal, squeeze it, he's got a diamond to give to, what's their name, but olive oil. And they've learned today, just in the last 20 years, I guess, how to make diamonds that are just indistinguishable from natural diamonds. High pressure. They've been doing it for years, making artificial diamonds, but they can't get them very big. Now, just I think in 2005, they were able to get big diamonds with a synthetic process.
They do it with pets and loved ones.
Take your pet, that's right. Burn the body, cremate it, press right into a diamond, and you can wear your dog the rest of your life, or something, or your ex-wife, or whatever. I don't think I'd want to do that. We were talking about that on the radio yesterday. Anyway, the guy said these diamonds even have carbon-14. It says this cannot be contaminated. Those constitute very strong evidence the Earth is only thousands, not billions of years old. Now, the Rate Project book is difficult reading, heavy reading. Jonathan, you're awful smart. How far did you make it through the book?
About halfway right now.
About halfway, and it's taken you
Almost a year.
almost a year. Yeah, it's heavy reading. If you want the simplified, don't go down quite so deep version, this one is excellent by Donald DeYoung, Thousands, Not Billions. He kind of summarizes in real English what they said. Different ways to show, look, it's not billions of years old. But the carbon dating assumptions need to be pointed out. They'll say, well, we know carbon decays at a certain rate, and so we know if it's only got half as much, it's half as old. There's some assumptions that mess up everything. I'll show you how it works. If I said, we're going to fill a barrel with water. So I hand Leah the hose. Here, Leah, fill this barrel with water. But what you don't know is I have drilled holes in the barrel. While you're putting it in, the water's leaking out. It's kind of like your checkbook. You keep putting it in and it keeps leaking out someplace, right? How many discovered that as you live along? Got the ring, Jonathan? You're discovering now, right? Well, the Earth's atmosphere is kind of like this barrel. It's always getting brand new carbon-14, 21 pounds every year, being put in. And it's always leaking out through decay. So the question would be, how long would it take to reach a stage called equilibrium? Now with a barrel, you can actually do the math and calculate. If I'm going to put in a certain amount of water per minute and a certain amount per minute leaks out, when will I reach equilibrium and where? That can all be calculated, with a little bit of math. And with the atmosphere, they said, well, when would the atmosphere reach equilibrium? So the guys who invented carbon dating in the late 40s said, I wonder about this Earth's atmosphere reaching equilibrium. They did a bunch of studies on that and said, now if we took a brand new planet Earth, created it from scratch, poof, got it going around the sun, how long would it take to reach this equilibrium point in the atmosphere where the production rate and the destruction rate is the same? And they determined it would take about 30,000 years to reach equilibrium. I'm not sure how they did all that. You could probably see some of the rate scientists and figure that out. But then they made two mistakes in my totally unbiased opinion. They said, number one, we know the Earth is millions of years old. Mistake number one. Number two, they said we can ignore the equilibrium problem because we would have passed that point 30,000 years ago. They've discovered the Earth has still not reached equilibrium. Radiocarbon is still forming 30 to 40% faster than it's decaying. Now think about that. If radiocarbon is still forming faster than it's decaying, that means the Earth is less than 30,000 years old, number one. And number two, you can't carbon date anything. Because you'd have to know when it lived so that you could calculate when it lived. You would have to already know when it lived to figure how much carbon-14 was it breathing at that time. Doesn't work. There's a website, www.arky.org. He's got more stuff on the Earth has not reached equilibrium, if you want some articles there, by Ron Cooper. But this is a calibration curve. If an animal is still alive, it should give you about 16 clicks on your Geiger counter per minute per gram. If you're only getting 8, you say it's been through 1 half-life, or 4 clicks, or it's been through 2 half-lives, or 3 half-lives, etc. This is called a calibration curve. In theory, it sounds like it should work, but there are several real obvious assumptions, and I don't know how they don't see it. Suppose you walked into a room, and I said, I want you to tell me, here's this candle burning on a table. When was it lit? Find out it's 7 inches tall. I said, well, that won't tell me anything. Now we've got to measure how fast it's burning. We measure the candle for a while. We get an Olympic stopwatch and we get it down to the nearest 40 bazillionths of a second, okay? And we all agree the candle is burning an inch an hour. Here's our two facts. 7 inches tall, burning an inch an hour. When was it lit? Mary, can't figure it out? Nobody can figure it out. Unless you make some assumptions. Assumption number one, how tall was the candle? And assumption number two, has it always burned at the same rate? Neither of those can be known. If you find a fossil in the dirt, the amount of carbon can be measured, the rate of decay can be determined. I don't argue with either of those. How much was in it when it lived? I don't know. Has it always decayed at the same rate? I don't know. Has it been contaminated, sitting there in the ground for all these millions of years? There's no way to know those things. If the Earth had a canopy of water above the atmosphere, or a canopy of ice, as we cover on Seminar 2, That would have blocked out a lot of radiation from the sun, which would have prevented most of the carbon-14 from even forming. So animals that lived before the flood would have lived in a world with much less carbon-14 to begin with, maybe none, but certainly less. And when we dig up the fossil that's been buried for 4,400 years, let's say it started with 4, where today we start with 16. We dig it up 4,400 years after the flood and say, wow, here's a mammoth that got buried, and it's carbon dated. Well, we're assuming it started at 16. When we test it and find it's got 2, we're going to say, oh, it's been through 4 half-lives, when it's actually only been through 1 half-life. Which is why it never works. When they first invented carbon dating, 1949, Willard Libby, they did some testing and they said the lower leg of a mammoth was 15,000 years old, but the skin was 21,000. How can 2 parts of the same animal be different ages? Quite obviously, we know one of the numbers is wrong. So how would you know either of them are right? And if either one's right, how would you know which one? I see no way to tell. Well, let's see if it's getting better. 14 years later, they tested a living mollusk, a clam, and it was 2,300 years old. Still alive. In 1970, at the Nobel Symposium, they said, if a carbon date supports our theories, we put it in the main text. If it does not entirely contradict them, we put it in a footnote. If it's completely out of date, we just drop it. You mean they can pick and choose any numbers they want? Exactly correct. If the number doesn't fit what they expected, they throw the number out. 1971, freshly killed seal was 1,300 years old when they carbon dated it. Troubles with carbon dating are undeniably deep and serious. Despite 35 years of technological refinement and better understanding, the underlying assumptions have been strongly challenged and warnings are out that radiocarbon dating may soon find itself in a crisis situation. Continuing use of the method depends on a fix-it-as-we-go approach, allowing for contamination here, fractionation there, and calibration wherever possible. It should be no surprise then that fully half the dates are rejected. Did you follow that? Out of thousands of carbon dates that have been carbon dating times that they've done it, half of the numbers are thrown out. How do they know they're wrong? And also, how would you know the other half is right? If half your test results have to be thrown out, it ought to raise red flags in somebody's brain. Wait a minute. This is stupid. What are we doing? We're wasting our time here. And the article goes on to say, the wonder is, surely, that the remaining half have come to be accepted. No matter how useful it is, the radiocarbon method is still not capable of yielding accurate and reliable results. There are gross discrepancies, the chronology is uneven and relative, and the accepted dates are actually selected dates. This whole blessed thing is nothing but 13th century alchemy. And I agree. That's 1981. Now, I've got all these in chronological order. It never gets better. 1984, living snails carbon dated 27,000 years old. 1992, 2 mammoths found side by side. They carbon date them. One is 22,000, the other is 16,000. Which one's right? Or are both of them wrong? Or are both of them right? There is no possible way to tell. In 1996, Carl Swisher at Berkeley University used the most advanced techniques to date human fossils. It says last spring he was reevaluating Homo erectus skulls found in Java in the 1930s. He was testing the sediment found with them. The species was supposed to be extinct for 250,000 years. Swisher used 2 different dating methods. He kept making the same startling find. The bones were 53,000 years at most, and possibly no more than 27,000. Well, I'd like to point out 2 things here. He's looking for 250,000 as his answer, but he keeps getting 53 to 27,000, okay? Which is only 1/4 of what he wants, 1/5 of what he wants, okay? But he's still getting a 96% error. I mean, is it 27,000 or 53,000? This is not an exact science. So when they publish an article in the paper and say, we found a dinosaur bone or a mammoth bone, and it was, 17,221 years old in 6 months and 3 days. Like, right, come on. You don't know that. They're making up this stuff, just absolutely making it up. Professor Rainer Prach von Zeiten, earlier the February of 2005, was resigned from a professor because he'd been lying about carbon dating for years. His frauds were exposed in February of 2005. He had dated the Bishkopf spire skeleton at 21,300 years old, but when they tested him at Oxford, they said it's only 3,300 years old. 700% error. He had said, Professor Protsch had said he had found the oldest German, the first German to ever move to Germany, 27,400 years old. They tested it at Oxford and said, this is an old man that died in 1750. He's 250 years old. The professor had been lying about this stuff for decades, and so he finally resigned in disgrace. Well, he should, okay? One part of a mammoth dated 29,000 years old, another part was 44,000. You talk about a slow birth. That would be it, okay? I like this article from Rand McNally. The last 2 years, an absolute date was obtained for the Gandong beds above the Trinil beds. That's in Indonesia. It has the interesting value of 300,000 years, plus or minus 300,000 years. Boy, they nailed that one right on the head, didn't they? Plus or minus, 300% error. In the Geological Survey Professional Paper 862, and I get some flack over this, but I've got the paper in the library somewhere. We couldn't find it here. There's all kinds of articles about carbon dating things in Alaska. I just want to show you a few things here. They carbon dated sample number SI-454. See that on the map there, on the chart there? And said it was 17,210 years, plus or minus 500. Then they tested sample SI-455 and said it's 24,140 years old. Well, 17,000, 24,000, say, wow, that's working good, until you find out that's the same sample as 454. Very same sample. Test it again. So is it 17,000 or 24,000? Sample number 299 was less than 20,000 years old. That little caret means less than. Sample number L137X is greater than 28,000. We say, well, see, it's working good. This sample is less than 20,000. This other sample is greater than 28, until you find out it's the same sample as 299. How can a sample be less than 20 and greater than 28 at the same time? I taught algebra for a long time. I don't think you can do such a thing. That's not too good. Living penguins were dated at 8,000 years old. Materials from layers where dinosaur bones were found are carbon dated 34,000 years old. I was in a debate one time and this professor was getting so upset. Finally he said, how can you use Reader's Digest as a resource? I said, sir, I use Reader's Digest as a resource for the picture of the dinosaur bone, okay? It's not the resource for the fact, okay? That's where I got the picture from. Oh, okay. So we went on to the debate. But yes, dinosaurs ought to date, 70 million years old. A Russian scientist dated dinosaur bones at less than 30,000 years old. Hugh Miller from Columbus, Ohio, took in 4 dinosaur bone samples and said, would you carbon date these? And they charge like $600 to carbon date something. They carbon dated them and said they're less than 20,000 years old. He said, oh, by the way, these are dinosaur bones. They said, oh, well, then they're not 20,000. We got to test them again. Why can't they be 20,000? They said, well, we know dinosaurs lived 70 million years ago, so if you had told us that, we never would have carbon dated them. One friend of mine died here several years ago, but he was doing a lot of archaeological work, and he dug down in this well and he found layers of burned wood, which is good to carbon date because obviously, it had carbon in it. And he put them in a baggie, sample number A, from such and such a layer. How many feet down? He labeled it A. Dug down 10 more feet, hit another layer of burned wood. A city had been destroyed, or 20 feet, whatever it was. He labeled it sample B. He took them in to have them carbon dated. Paid them the $600. They said sample A is, I forget, 3,000 years old and this one's 4,000 years old. He waited 6 months, switched the labels, took them back in, same laboratory, said, I want you to carbon date these samples. Now, sample B, the lower one, is in the top bag. So just switch the labels, and they give them the same results, 3,000 and 4,000. It doesn't work. It's never worked. Here's things to consider about carbon dating. When the sample of, date a sample of known age, it doesn't work. If you date a sample of unknown age, it is assumed to work. That's not science, okay? As things decay, they produce helium. This helium, the amount of helium in the atmosphere is only enough to account for a few thousand or few million years, not billions of years. There's a book called The Mythology of Modern Dating Methods by ICR, if you want to read stuff on that. They do a lot of testing on this. They're probably the experts in the creation community. This guy said, the rocks do date the fossils, but the fossils date the rocks more accurately. That's ludicrous, okay? And it all based on circular reasoning. They've known that for centuries. We'll cover more on that on video 4. I talked to James P. Dawson, he's going to be on our radio program tonight, actually, Jonathan. He's supposed to call in. James Dawson was one of the guys working on dating the moon rocks. They brought back moon rocks, gave them to his laboratory, and said, how old is the moon rock? He took specimen number 10017, divided it into 6 pieces, and tested it many, many times. How old is it? They got numbers ranging from 2.5 billion to 4.6 billion. That's a 500% error, or 100% error. I talked to him back in '99, and he's in Oklahoma. There's his phone number. He was Chief of Engineering and Operations for the Lunar and Earth Science Division of the Manned Spacecraft Center in NASA in Houston. He worked on lunar samples, including the Genesis rock. He told me they found ages from 10,000 years to several billion in the same rock. His website, jpdawson.com. How can one rock be 10,000 years old and several billion years old at the same time? Something is wrong, okay? The book Bones of Contention has a great chapter at the end called The Dating Game, showing how that they will just change the dates whenever necessary. If it doesn't fit the theory, oh, let's test it again until it fits the theory. See, the theory is important. The facts are not. Evolution, as I've said many times, is a carefully protected state religion. And that's all it is. What about potassium-argon dating? Does that work? Actually, the numbers are bigger, but the problems and assumptions are exactly the same, and you can demonstrate it doesn't work. Potassium decays very slowly. This chart shows the different elements in their half-life. Carbon has a half-life around 5,700 years, but potassium, it takes 1.3 billion years with a B for half of that to disappear. Very slowly decays. By the way, I would like to point out, Your Honor, just for, appeal, that all of the dating methods are based on the decay of an element. Uranium decays to lead. Potassium decays to argon. They're all moving down the periodic table, not up. All going down. Just point out, keep that in mind in case we need to appeal this case, all right? 80% of the potassium in a small sample of iron meteorite can be removed by distilled water in 4.5 hours. Well, if you can take out 80% of it in 4.5 hours, how can you trust any dates you're going to obtain by that? Canadian Journal of Earth Science ran an article and said, in conventional interpretation of potassium-argon age, it's common to discard ages which are substantially too high or too low compared to the rest of the group, or with other available data such as the geologic time scale. There it is. If you test a sample and its number's too high or too low or doesn't match the geologic column, it gets thrown out. Well, then why are you wasting your time and money testing it? You already know how old you'd like it to be. Give it a number. Pick a number. It's dumb. The KBS tuff, a tuff is a layer of ash or lava, or generally ash that has been packed and turned into rock. It's called tuff, T-U-F-F. K. Brenzenmeyer had been dating these samples of with potassium-argon dating because here's the theory. When a volcano erupts, the rocks and stuff coming out is really hot and any gases in it should be able to escape. Well, potassium slowly turns into argon, and argon is a gas. They use it for welding over at the shop. Argon welding, Argon's a gas. So since potassium turns to argon, when the rock gets melted and shot out of a volcano, all the gas escapes. And so the theory says this new layer should have been, the clock is now reset. It is 0 years old. Even though when it was in the earth, it's 4 billion years old. Now all the argon's gone because it accumulated this argon for millions of years, but now poof, it melted and the gas is gone. So we can potassium-argon date this lava or ash or any volcanic material. Well, they had been dating this layer of ash named after Kay Brenzenmeyer because she did research on it. They said it's 212 to 230 million years old. All the scientists agreed that layer of ash is around 200 million years old. Until Richard Leakey came along in 1972, and he's digging around under the KBS tuff, and he finds a perfectly normal human skull. Everybody panicked and said, wow, how can you have a normal human skull under 200 million year old rock when man didn't even evolve till like 3 million years ago? That's not possible. And so they looked for things. Was this a burial? Did somebody dig through the rock and bury this person down here? Was there an earthquake? Is there a fault line near here someplace? Nope. All we can conclude is there's a normal human skull under 200 million year old rock. So, what do you conclude? Well, one group studied this and said, well, that proves aliens came here 200 million years ago. Would you just consider that maybe the rock's not 200 million years old? After they found out it could not be an intrusion or a burial or anything else, it had to be legitimately placed there. I mean, the person was buried under this ash layer. They took 10 more samples of the KBS tuff and dated them again. Keep in mind, they'd already dated them a bunch of times. And everybody agreed it's 212 million years old. But now they take 10 more samples and check them again and say, oh no, it's only 0.5 to 2.6 million. Well, that's way down from 212. Okay, they dropped the number way down. But they're still getting a 500% error from 0.5 to 2.6. This is not an exact science. See, back in 1770, they taught the kids the Earth is 70,000 years old. In 1905, they said it's 2 billion years old. By 1969, when I was a kid and they went to the moon, they brought back moon rocks and said, oh wow, they're 3.5 billion years old. That was the official age, 3.5 billion. Today they tell, and by the way, they did it with potassium argon dating. You can see the article here from the newspaper. Today they tell the kids it's 4.6 billion years old. Do you realize the Earth is getting older at the rate of 21 million years per year? That's 40 years per minute. While dates are always obtained with carbon dating or potassium argon dating, dates that don't fit the theory are rejected. Only the correct dates ever get published. Well, then why are you wasting anybody's time? Why? It's not science. The original content cannot possibly be known. You can't know there's been no contamination. You can't know that the decay rates always remain the same. You can't know those things, okay? I'll give you a couple examples of potassium argon problems and then we'll take a little break. Basalt from Mount Etna in Sicily. By the way, I climbed on Mount Etna when I was over there in Sicily. They knew it erupted in 122 BC. They said they knew it erupted in 122 BC. There were written records. Well, the potassium argon dated it and said it's 2.25 million years old. Excuse me? It should be like 2,000. When they tested lava from a Hawaiian volcano, they knew it erupted in 1801. The people watched it happen. That's the lava flow that covered our village, 1801. It gave an age of 1.6 million years old. That's in 1968. Let's see if it gets better. Basalt from a volcano in Hawaii erupted in 1959. When they tested it, it gave an age of 8.5 million years old. Another volcano in Mount Etna from the 1964 eruption gave an age of 700,000. The 72 eruption gave an age of 350,000. It was erupting when I was over there in 2002, I believe. I don't remember. Lava from Mount St. Helens was tested, which my sister lives just 60 miles from there. They tested the lava from Mount St. Helens, brand new lava coming out of the volcano. Grab a sample. How old is it? They tested it 5 different ways and got 5 different numbers. All the way from 350,000 to 2.8 billion. Notice, all 5 numbers are different, number 1, and all 5 numbers are wrong, number 2. They're wrong. It doesn't work. So again, when you test a sample of known age, it's assumed to work, and if you test a sample of unknown age, it is, we know it doesn't work when you know the age, but when you don't know the age, well then they say it works. So it just doesn't work. And I'm tired of them using our tax dollars to call that science. That is not science. That's pure imagination. There's a whole bunch more in the book, Evolution Cruncher, if you want more on that, or in the RATE project book, Radioactive Isotopes and the Age of the Earth, if you want more. Or there's a whole lot of good stuff in Walt Brown's book, In the Beginning. He's a PhD in physics, Air Force Academy professor for years in Colorado. Got great stuff in here.